I'm probably going to put one of these in there because I feel like we should know how to do these. These are the questions that have been giving us issues. I'm not saying that I'm warmed up because I haven't done this exact question, but I've done these questions with you guys, the ones that have been asking me. So I might make a mistake, so I'm going to need your assistance. All of these questions are questions that you guys are getting wrong in large numbers. So do you have a calculator with you? Okay. Awesome. You bought one? I like it. Yeah, that will get the job done. Okay. So this up here is supposedly you guys asking questions. And it says, Chav, I'm using kinematic equations and I still can't get an answer. How do I do question number 6 from UH Quiz 10 rates? Don't use kinematic equations. Yes, I know you can get the answer with kinematics. You can. We did it last time using kinematics. Here's how you do it. A falling stone is at a certain instant 90 feet above the ground. So I'm going to write y of t at a certain instant. So t1 is equal 90. 2 seconds later, it is only 10 feet above the ground. So I'm going to write y of t1 plus 2. It is 10. And I guess I should be putting units here, feet and feet. If it was thrown down with an initial speed of 4 feet per second, so I'm going to write v of 0 equals negative 4 feet per second. From what height was it thrown? So what do I want to know? I really want to know y of 0. Question mark. I want to know from what height was it thrown. Does that make sense to you guys? We're going to say that down is negative, and we're going to say that up is positive. So here we go. It always, this is assuming you're on Earth. Acceleration due to gravity on Earth, I know it's 9.8, but because look at the units, we're in feet. So we need it in feet per second, or feet per second squared. So acceleration on Earth due to, in English units, is 32 feet per second squared. Are we okay with that? All right. Now, I need to get a velocity expression. To do that, I need to do something called a what? Antiderivative. And I know we haven't formally had a lesson on antiderivatives. That's coming. But it's this concept's pretty straightforward. So we're going to do the antiderivative of negative 32, which is? Yeah, you always got to put the plus c in there, guys. Now, I know that initially my velocity was negative 4. So negative 4 equals negative 32 times 0 plus c. And I know that a lot of you can figure out that c is negative 4 without doing that. But do that to show the reader that you know how to calculate your c. So from that, I can say that my v of t expression is negative 32t minus 4. If I plug in a 0, I get a negative 4. Yes, ma'am. Oh, right here, they told me that my initial speed is 4 feet per second downward. You see it? If it was thrown down with an initial speed of 4 feet per second, so that means v of 0 is negative 4. No. V of t is an expression that tells me my velocity at any time t. V of 0 is my initial velocity. See, this tells me my velocity at any time t. If I told you what's my velocity at 0, you plug in a time at t equals 0, you plug in t equals 0, you get negative 4. If I told you what's my velocity at t equals 1, you plug in a t equals 1, and you'll get negative 36. So at t equals 1, my velocity is 36 feet per second going down. Did I answer your question? Gonzalez? Okay. Are we okay so far, guys? All right. Now, how do I get my position equation from velocity? I do a what? Antiderivative. So here I go. I'm writing y of t because this is motion up and down, guys. So add 1 to that exponent, divide by that number. So it's going to be what? Negative 16t squared minus 4t plus c. This is my expression. I'm going to solve for c. When I solve for c, you're done with calculus. When you solve for C, that is how high this object is. Chavez, I don't understand. Why when you solve for C, is that the height of the object? Because we're looking for what was the height at 0. Do you guys see that? When I plug in a 0, all you have is C. So that's why. So here we go. I'm going to plug in. You're done. Now you're just doing math, like general math from your systems of equations. So here we go. I'm going to plug in T1. So I'm going to write 90 equals negative 16, parenthesis T1, close it, squared, minus 4, parenthesis T1, close it, plus, and I'm talking about a very specific constant, so I'm going to put C1. Is everyone okay with that? All right, that's equation 1. Title it equation 1. Equation 2, I'm going to plug in the 10. So 10 equals negative 16, parenthesis T1 plus 2, close it, squared, minus 4, parenthesis T1 plus 2, close it, plus that same specific value, because they're both the same. Does that make sense? Okay, so now you're done. You're just going to expand equation 2. So here's me expanding equation 2, guys. 10 equals negative 16. T1 times T1 is T1 squared, plus T1 times 2 is 2T1, but you're going to have how many of those? Well, 2 of them. So 4T1 plus 4. And then distribute this negative here. Minus 4T1 minus 8 plus C1. All I'm doing is expanding, guys. Distribute that negative 16. 10 equals negative 16 T1 squared minus 1632 64. T1 minus 64 minus 4T1 minus 8 plus C1. I'm going to combine like terms. 10 equals negative 16 T1 squared minus 68 T1 minus 64, 74, 72. 72 plus C1. And finally, I'm going to move the 72 to the other side. So 72 plus 10 is 82. So minus 68 T1 plus C1. There it is. That's equation 2. I'm going to write equation 1 right below it. I'm going to change the polarities of everything in equation 1. Is that okay? All right, so here we go. Equation 1, negative 90 equals a positive 16T1 squared plus 4T1 minus C1. Why did I do that? Yep. Yes. I did that so I can cancel out the 16T1 squared. So 82 minus 90, I believe that's negative 8. And negative 68 plus 4, I believe that's negative 64. And these C1s cancel out. So those are the same constant. So from that, I can get you that T1 is equal, negative divided by negative is A. And 8 goes into 64 8 times. So I have 1/8. Use that value to plug in. I would plug it into equation 1, guys, unless you really want to mess with that 2 there. Plug it into equation 1, and you'll get your C value now. So let me see. Do I got enough space? Okay. I'm going to write it in blue here. So 90 equals negative 16 parenthesis 1/8 squared. And I'm not saying this is the only way. I'm sure there's others. 4 times 1/8 plus C1. All right, let's see. 90 equals negative 16 parenthesis 1 over 64 minus a half plus C1. 16, 32. Oh, I'm just going to take my calculator. Is 16, 32, 1 negative 1/4, right? Negative 1/4 minus a half plus C1. So 90 equals negative 2, 3, negative 3/4. 50 cents and 25 cents plus C1. So C1 is equal to 90 plus 3/4. So let's see what that is. 9 times 4 is 36. So 360 plus 3. 363 over 4. And there it is, guys. Is that answer in here? It's just a little bit bigger than 90. Well, 90.75 feet. 90.75 feet. So do you think if you get this equation again, or this question again on an exam, do you think you can show all this work and get it right? You don't think? Do you know what we did? Okay, we're going to do it again. Check it out. Chav, my question doesn't have an initial speed thrown, but it asks from what height it was dropped. Is this the same as the question we just did? That's supposed to be you guys. Yeah, it's the same, guys. The only difference is if it was dropped. Okay, next time I'm going to let you guys read it. If it was dropped, what's your initial velocity? Yeah, 0. So let's see. A falling stone is at a certain instant 144 feet above the ground. So let's write that down. Y1 of T1, Y of T1 is equal to 144 feet. And Y T1 plus 2 seconds later, it is 16 feet. From what height was it dropped? Well, if it was dropped, that means my initial velocity is 0 feet per second. Does that make sense, Gonzalez? Okay, so tell me, what do I do first? Start with what? Perfect. The acceleration. Acceleration due to gravity on Earth is equal to what? Negative 32 feet per second, or feet per second squared. Now from there, what do I do? Take the antiderivative. You can write A of t there if you want. So V of t is equal to negative 32t plus c. But because my initial velocity is 0, that means my c must equal? No. 0. Because I dropped it. Or you can say 0 equals negative 32 times 0 plus c. So from that, c equals 0. Does that make sense, Gonzalez? Oh, because you see how I wrote v of 0 equals 0? So here's my velocity equation. So I write 0 here equals negative 32 times time, which is 0, plus c. So 32 times 0 is 0, so c has to equal 0. That makes sense? All right. Here we go, guys. So I know my velocity expression is just negative 32t. I need my position equation. So I'm going to do another antiderivative. What's the antiderivative of negative 32t? Plus a specific c. So I'm going to write c1, or c subscript of 1. Here we go. I'm going to plug in these values. You're done with calculus. Now you're doing a system. Like what you did in Algebra 2, guys. System of equations. Y1, or y. So 144 equals negative 16, parenthesis, t1, close it, squared, plus c1. Equation 2. And that should be an equal sign there. It just didn't come out. 16 equals negative 16, parenthesis, t1 plus 2, close it, squared, plus that specific value. All right, here we go, guys. I'm going to expand it. I'm going to expand equation 2. So equation 2, 16 equals negative 16 parenthesis t1 squared plus 4t1 plus 4, close it, plus that specific c1. Distribute the negative 16. We're a little warmed up already because we just did the same thing with the same numbers. Negative 16 t1 squared minus 64 t1 minus 64 plus c1. That's equation 2. I'm going to write equation 1 right below it, but I'm going to change the polarity so I can add them and cancel. Yes. Oh, yeah. Let's do that first. 64 plus 16. Is that 80? 80 equals negative 16t1 squared minus 64t1 plus c1. Now we can do it. Here's equation 1. 144, negative 144 equals positive 16t1 squared minus c1. I should have written the c1 over there, but that's fine. The c1s cancel out. The 16t1 squares cancel out. What's 80 minus 144? 44, 54, 64. Negative 64 equals negative 64t1. They're being nice to me. t1 equals 1. So now I just take that t1 and I'm going to plug it in right here. So I'm going to change it to blue, guys. 144 equals negative 16 times parentheses 1 squared plus C1. So 144 equals negative 16 plus C1. C1 equals 144 plus 16, which is 44, 64, 70. 144, 54. Oh, I can't add 60. 44, 54, 60. Yep. 160 feet. What do you think, Gonzalez? Now, why is this the value, guys? Because this completes my equation. In case you're wondering, like, Chav, I don't know what you're doing. Well, if I want to know from what position I let it go, like what's the height that I dropped it in, that means t equals 0. So y of 0 is 160, so that means I'm 160 feet above the air. Does that make sense? What do you think, Valencia? All right. Yeah. All right, Abdul Kareem. Can you read the quotes on the next page, please? And I gave you a whole bunch of awkward emojis over and over again. All right, so you're right to a certain extent. We have talked about when we move to the right, when we move to the left, but we haven't explicitly spoken about when we speed up and slow down. I think we have one time, but we didn't like do a problem, like a real problem. If you would have looked at my video on UH Quiz 10 rates, I did talk about this question. Remember, guys, we only have so much time, and we can't do every single question. I try, but we can't do every single question in class unless you come after school and we talk about a question you don't know. All right, let's talk real quick basics. If my velocity is positive and my acceleration is positive, am I speeding up or slowing down? Speeding up. My velocity and acceleration are in the same direction. Does that make sense? Ramirez, that makes sense? Okay. If velocity is negative and acceleration is negative, am I speeding up or slowing down? Speeding up again. Think about it. Velocity negative means you're moving left, and acceleration negative means the force is applied in the same direction. So I'm speeding up again. Does that make sense? Okay, velocity is positive, so you're moving right, but acceleration is negative. Are the forces opposite? So I am what? I am slowing down. Velocity positive, acceleration is in the opposite direction. So you're still moving to the right, but you're slowing down because forces oppose each other. If acceleration is negative, but velocity is positive, you are slowing down again. You're moving to the left, but the acceleration is in the opposite direction. You're still moving to the left, but since the acceleration is in the opposite direction, you must be slowing down. Does that make sense? So what did we just conclude? In order to be speeding up, or I guess in this case, slow down, in order to be slowing down, velocity and acceleration must have what? Opposite signs. Write that down, guys. That's your notes. I'll write it down here for you. In order for a particle to be slowing down, comma, velocity and acceleration must, and then underline, double underline the must, have opposite signs. Yeah, perfect. Same thing. Does that make sense to everyone? Okay, so are we happy that we're here getting all these good notes? Okay, look at all this awesome stuff, guys. Okay, so here we go. I have a position equation. This will tell me, by the way, in case you're wondering, Chav, why does this one say x of t and the other one we did had y of t? Well, the other one was particle in the y-axis only. This right here, because it says x of t, this is only moving what or what? Left or right. When you get to Cal BC, the next calculus, you'll have two dimensionals, x, left, right, up, down. And when you get to multivariable, you do 3 dimensions. Left, right, up, down, and, well, I guess, x plane, y plane, z plane. X, y plane, x, z plane, and 3 dimensions, x, y, z, I, j, k. They use the dots I, j, and k. Okay, anyways, I'll stop talking. Here we go. How do I find velocity from position? Take a derivative. So here it goes. V of t equals, if you want to write, which I think we should, write x prime of t equals v of t, so we can have good notes. So the derivative of position is velocity, and then the derivative is negative what? Perfect. Now I'm going to do something called critical numbers, which we haven't done a formal notes on, but we will. What does it mean? I'm going to equal that to 0. I am finding where I either move left or right, or actually at 0, you're finding where where you're at rest. So I'm going to factor out a t. I'm going to factor out a negative t, and I'm going to write t squared minus 75. So from there, I get 3 critical numbers. T equals 0. And then let's see, let me write this down here so everyone can see. T squared minus 75 equals 0. T squared equals 75. Square root. T equals, let's see, 75 breaks down to 25 times 3. So 5 square root of 3, you don't care about the negative because t has to be greater than or equal to 0. 25 times 3? Oh yeah, you don't care about the negative because of that right there. Okay, sorry, I didn't hear your question. I like to do what is called, well, we call it railroad tracks. I don't think that's the official name. In the math world, we call this a number line. And I'm going to put v for velocity, and that's 0. And I'm going to put 5 square root of 3 right here. All I care about, that's the only critical number I got, 0 and 5 square root of 3, but 0 is my initial anyway, so. All you care about is whether it's positive or negative. That's it. So give me a number between 0 and 5 square root of 3. Any number. 1 or pi. Yeah, you don't want to make it complicated. 1. If I plug in a 1, it doesn't matter where you plug it in. You can plug it into this one. You can plug it into this one. I'm going to use the second one down here. If I plug in a 1, 1 squared is 1. 1 minus 75 is a negative. And then a negative times a negative is a. So I see a plus right there. Chav, how do you know what's a number bigger than 5 square root of 3? Like this, guys. What's the square root of 4? So 5 square root of 4 would have been 10, because 5 times 2. So I'm going to use 10. Do you guys see how I did it? So 10, does everyone agree that 10 is bigger than 5 square root of 3? All right. If I plug in a 10, 10 squared is 100. 100 minus 75 is a positive. On the outside, I have a negative, because it's negative 10. So what's negative times a positive? Negative. There it is. It's negative forever after that. But that's not the answer. I just needed that. Now remember what we said here in my little thing. That we need also what else do we need? All right. Let's find the acceleration. Let's go back to the first expression there. So to take the acceleration, or to find the acceleration, I got to take a what? A derivative of velocity, which happens to be the second derivative of position. So I'm going to write x prime prime of t, which equals to v prime of t. Do you see how everything's connected? And that is equal to the acceleration, a of t. There it is. You probably don't have to do all that. This is probably overkill, but right now we're rookies, so here it is. And is equal to negative 3t squared plus 75. Again, I'm going to equal this to 0. So let's see. So negative 3t squared equals negative 75. I moved it to the other side. Divide by negative 3, divide by negative 3. T squared is equal to 25, square root. T is equal to 5. I come back over here, right below the velocity curve, and I'm going to call this acceleration, A. And I know that 5, is 5 bigger than or smaller than 5 squared root of 3? Smaller. Doesn't matter where you put it, but I'm going to put it to, as long as you put it to the left of 5 square root of 3 because I'm trying to say that these are equivalent. So I'm going to say that's 5. You guys ready? I'm going to plug in a value in here, into this expression. That's my acceleration. A number between 1 and 5, any number. 3. Okay, 3 squared is 9. 9 times negative 3 is negative 27. Negative 27 plus 75. Is that a positive or negative? Positive. Give me any number bigger than 5. 8, 10, 10. It doesn't matter, guys. It doesn't matter. 10 squared. 10 squared is 100. 100 times 3 is negative 300. Negative 300 plus 75. Negative. Okay, now check it out. Try to break it up into little intervals like this. And then you can see already. Where do I have my velocity and acceleration with opposite signs? Between. Perfect. Do you guys see at between 5 and 5 squared root of 3, the velocity is positive, but the acceleration is negative? Do you guys see that? So between 5 and 5 squared root of 3, my particle must be slowing down. So that's what I'm going to write. I'm going to write particle is slowing down on time interval. Here's how you would write it on the AP exam if it were free response. 5 comma 5 square root of 3, since on this interval velocity and acceleration have opposite signs. Full credit. Obviously, this is multiple choice, so you don't need to write a statement. But if it were free response, you would want a statement. How do we feel, guys? Okay. What do you think, Valencia? Is this good stuff? Math life? Yeah. I'm hyped. Extra points for everyone. 5 points everyone. I can't do that today. I can't do that. All right. All right, Abdul Karim, can you do us the honorable, can you read that statement as a student there?
All right, Tom. One more question. Mm-hmm. Question 12 on which race has that one second. I'm supposed to figure out how fast the shadow is. How do I even start with that?
Oh, I like that. I like that. All right. Have you guys ever, I don't know. This is just real life stuff. Have you guys ever walked under a lamppost to see how big your shadow is? If you're directly under the lamppost, is your shadow big or small? Small. And if you walk away from the lamppost, does your shadow get bigger or smaller? Bigger. It gets bigger. Right? So as soon as I'm not trying to tell you to look at the answer choices and eliminate some, but if I were going to eliminate answer choices, what answer choices would I delete? I would delete A and C because I know that my shadow is getting bigger as I walk away. Does that make sense? All right. Draw a picture. So here's my lamppost. And here's that dude. Yes, I am. Should I not? Oh.
No, you should.
Okay. So here's the lamppost and here's that dude. So this is a ray of light. And let me see if I can capture it just perfect. Perfect. This distance between this guy and the end of that ray, that's your shadow. Shadow. And the distance between the lamppost and this man, we're going to call that X. This man is 6 feet tall, so I'm going to label 6 because he is 6 feet tall. So let me write down what we know. We know that he is 11 feet from the post, so X equals 11. And then we know that the shadow, I'm going to use the letter S for shadow, guys. That's not a 5, is 3 feet. Let's see, what else do we know? Yeah. He walks away, so he's moving to the right, the way I have my picture there. If I would have drawn the lamp to the right, then I would have written dxdt as a negative. He walks away at 450 feet per second. And depending on how you draw your picture, that 450 is either positive or negative. It's going to work out no matter what, as long as you do the model correctly. Cool or not cool? All right, so here we go. I need to figure out how fast that shadow is moving, because that's what I want. At what rate in feet per minute will the length of a shadow be changing? So they want ds dt, question mark. Cool or not cool? Before I can answer that, I need to figure out the length of that lamppost. So here's what I'm going to do. Do you see similar triangles right here? You see that one in green? And you see that big one in red? So that's what I'm going to do. So I'm going to go 6 is to 3. That's the length of the shadow. As the lamppost, L, is to 11 plus 3, 14. Does everyone know where I got those values? All right, so here we go. I'm just going to solve for L, guys. 2 equals L over 14. L is 28. You don't have to do that. You can do it in any other way. You could have gone 6 times 14 divided by 3. 11 plus 3. X is 11. The shadow is 3. Is everyone okay? Okay, does everyone know why I wrote 28 right there at the lampposts? It's a static number. It's not changing. Whatever is changing, do not write any numbers on that. All right, here we go. Now I'm going to do similar triangles. I'm going to write, let's see, 6 is to the shadow, S, as 28 is to X plus S. That is my model equation that I'm going to use. Is everyone okay? All right, cross multiply. So now I have 6x plus 6s is equal to 28s. Are we still okay? All right, I'm going to move the 6s to the right. So 6x equals 28 minus 6. What's that, 22? 22s. And I'm going to rewrite it 22s equals 6x. Mirror. And then I'm going to get the s by itself. You don't have to, but I want to. So I'm going to divide by 22. So the shadow equation is 6x over 22, which reduces to 3 over 11x, like that. You can write 3x if you want. So this is what I'm going to take a derivative with respect to time. So here we go. ds dt is equal to 3/11 dx dt. Do I have dx dt? So here we go. ds dt is equal to 3/11 times 450. Let me take my calculator. I'm going to go 3 over 11 times 450. And I get this number. It's ugly. Well, it's not ugly, but I want it in a fraction because my answer choices are in fractions. And there it is, 1350 over 11. Do I have a 1350 over 11? Okay. All right, guys. So be honest before I conclude here. Did going over these questions help? Yes. I never want to waste your time ever. So make sure you look over these questions. Make sure you know how to do them. And if you have any questions, please let me know. And let's tear it up. Let's finish up what we haven't finished up, guys.
Oh, sorry.